Talk about multiplicative relationship. That's where you have an independent and dependent, or independent and dependent variables, and you find a relationship, and it's through multiplication. The last one was nothing but through adding or additive. So before that, let's do our do now, because I think this is one that's over our last lesson of our additive relationship. Write an equation to determine the total amount Alexis earns given the amount she earns by babysitting. So if you look at this graph, we have to get the graph from this. If she babysits for she makes $1. Now she total earned is 6. So 1 is 6. The amount earned from babysitting is 2. Now she has a total earning of 7. And I think that the next one is 3, 8. Let's see, 3 is 8. So what is the relationship here? The relationship is plus 5, plus 5, plus 5. So how would you write this as an equation? So we're adding 5 to what variable? To x. So it's x plus 5, and it's set to y. That is our equation. So we're adding 5 to x, the amount earned by babysitting, and now we know her total amount she has made, y. So let's go back. Our equation is y equal x plus 5. So today's lesson will be the same thing, almost, but through multiplicative, or multiplication. So Andrea wants to buy a dress for a party. She plans to save $5 each week. Complete the table of value below for the amount of money that Andrea has in her saving account each week. So in 0 weeks, she earned $0. In 1 week, she made $5. 2 weeks, $10. 3 is $15. 4 is $20. 5 is $25. So the relationship is times 5. So how do you say that with W? So the thing is 5W. Again, some people are more used to X and Y, so this could be 5X, but since they use W as the variable instead of X, we say 5W. I'm not sure what is equal to, because they didn't give us a letter for this one. I guess it might be Y equals 5W. So write an expression for the amount of money earning each week. So it's 5W. Use the expression that you wrote in part 2 to determine how much money that Andrea will have after 15 weeks. So it's 5W, or 5, and the week is 15. 5 groups of 15 is $75. If Andrea has $35, use your expression, 5W, to write an equation that models the situation. So we know is 5W equal $35. Then solve the equation. Explain the meaning. So 5 groups of something is $35. 7, so it's 7 weeks. So in 7 weeks, she'll make $35 because she's getting paid $5 per week. Explain any connections that you see between a verbal description, table of values, graph, and equation. They're all equivalent. They all show the same relationship of $5. She makes $5 each week. Explain any connection that you see. Now let's graph it. In 0 weeks, she made $0. In 1 week, she makes $5. In 2 weeks, she makes $10. In 3 weeks, she makes $15. In 4 weeks, she makes $20. And so on and so on. So what would 5 weeks be? 25. 6 would be 30. 7 weeks will be $35. So Andrea's brother Daniel wants to buy a shirt for the party. So I guess that's it. I'm just missing a couple questions. 5, 6, 7. Oh, I skipped a whole page. I knew I skipped something. So let's go back. Graph the information. We just graphed it using your tables. And if Andrea has saved $30, write an equation that models it. So as we know, it's 5W equal 30. So what week would that be? 5 groups of 6. So that would be the 6th week. Can you use the graph to predict the number of weeks that would take Andrea to save $30? So let's go to our graph. From our graph, could we figure out what 30 would be? Because yeah, 5 would be 25, 6 would be 30. Yes, we could figure it out. And if Andrea has saved $20, write an equation that models the situation. So 5 weeks is $20. So 5 groups of what week? 4 will be 20. So it's a 4-week. How can you use the table to find this? So we go back to our table. 4 weeks is $20. And last but not least, write an equation that shows the relationship between the number of weeks and the dollars that Andrea has saved, D. Oh, so this was D. This is W. So what would our equation be? 5W equal D, or D is equal to 5W. Again, some people are used to writing X and Y, so they might have written Y equal 5X. Just substitute the X with a W and the Y with a D. So let's do our next question. So Daniel wants to buy a shirt for this party. Daniel plans to save $10 more than the number of weeks. Complete the table. So in 0 weeks, he has saved $10. He saved $10 more than the number of weeks. So in 1 week, so $10 more, that will be 11. $10 more, that would be 12. $10 more is 13. $10 more is 14. $10 more is 15. So we're adding, the relationship is adding 10. So how would you say this as an expression? W plus 10. If this was D, how would you say that as an equation? D is equal to W plus 10. So graph this now using a different crayon. So let's go back to and graph it. So in 0 week, it's $10. In 1 week, it's 11. In 2 weeks, is this. It's $12. 3 weeks is $13. 4 weeks is $14, and so on. So this one is Daniel, and this one is Andrea. So let's go back and answer questions about this. We graphed it already. Write an equation that shows. So we did D is equal to W plus 10 because it's an additive one, while the other one was multiplicative. Which person added? Which one person has an additive? Daniel. In Daniel, you have to add 10 to find how much money he has for that week. While her sister, Andrea, has a multiplicative. She makes $5 per week. So you can find the number of weeks and you multiply by 5. So now let's answer some questions using what we know. This is like a culmination lesson of what we've been doing for the last 7 days about relationships. Melinda pays $375 in car payments each month. Which table best represents the relationship between M, the months, and seating? So let's go to the first one. What is the relationship from 3 to 1,200? That's times 400. Is that the same relationship of paying $375 every month? No. B. In month to, I think it's written backward. Because to do this is dividing by 375. That is not. This one. Ooh, 1 month is $375. That's nice. And then in 2 months is $725. Let's see if that's correct. In 2 months you pay $375. That's $750. That is not the relationship. So D is. So in this one, the relationship is $375 per month. So 4 months, $1,500. 8 months, $3,000. 12 months is $4,500. The table below shows the relationship between the number of cafeteria tables and the number of seats per student. Which equation can be used to determine S, the number of seats per students, in terms of N, the number of cafeteria tables? So what's the relationship from here to here? Times 12. So how do you say it with the letter N? 12N equal S. No, the only one that shows 12N equal S, or S equal 12N, the number of seats equal to 12 groups of tables. So once you know the number of tables, you multiply by 12, and then you know the number of seats. That's why it's B. So this is the study of multiplicative relationship, where you have to multiply and write it as an expression, then write it as an equation. So pretty much what we've learned throughout this whole 7 days is finding the relationship, writing it with a letter, a variable, writing as an equation, setting up to what y is equal to, or whatever letter they give you that one, dependent and independent. So again, in a graph, dry mix, the independent is the x-axis, The dependent is the y-axis. So these numbers or these labels will be the independent, and these labels or these numbers will be the dependent. And that's study relationships.